guys, welcome back to the channel. The next problem in the series is a zero remainder array, and in this question you are given an array of integers and two other integers. One is k and another is x, which is initially set to 0, and we have to convert the array into a zero remainder array. And by saying that, what I mean is we have to convert this array into such an array such that every element of the resultant array is divisible by k. And for doing that, we are provided with two kinds of operations. In one operation, you can add x to any element of the array and then increment x by 1. And the second operation is you only increment x by 1. So you have to do the conversion in the minimum number of moves. And there is one more condition, that the first operation, that is adding x to any element of the array and then incrementing x by 1, this operation should be applied no more than once on a particular index. So let's take an example. Suppose k given to us is 3 and x is initially 0 and the array is 1, 2, 1, 3. 1, 2, 3 and 4. So we have to convert this array into such an array such that every element of this array is divisible by k in the minimum number of moves. Let me write down the moves. So the first move is you convert ai to ai plus x and then increment x. And the second move is you simply increment x. So these are the moves available. So for this particular question, my approach would be like this. Initially x is equal to 0, and what I'll be doing is I'll be choosing the second move. I'll increment x by 1, so x becomes 1. Then I'll choose the first move. The first move is I'll add x on some index. So I'll add x on this index. So it finally becomes 2 plus 1. So it becomes 3. And 3 is divisible by 3. And then increment x. So in this move, I add x on second index and then increment x to 2. Then again I'll be choosing the first move, that is I'll add x on some index in this array and that index would be first index. So I'll add x, which is 2, to this index. So it becomes 1 plus 2, which is 3, and it is divisible by 3. So in this move, x is added on the first index and then incremented, so x becomes 3. Then I'll be choosing the second move, that is increment x by 1, so x becomes 4. And then I'll be choosing second move again to increment x by 1, so x becomes 5. And finally I'll be choosing the first move. So I'll be adding x on some index in this array. So I'll be adding, that index would be this index. So I'll be adding 5 to 1, so it becomes 6. So finally the last move is applied on third index and x finally becomes 6. And this 3 is unchanged. So it is 3. This is finally the zero remainder array. That is, every element of this array is divisible by k. So let's do some analysis. So let's say the number on the ith index is a of I. This a of I is of the form t into k plus remainder. That is, I'm writing down this number in this form. So this would be the number k which is given to us, and this would be the quotient, and this would be the remainder. So for this number a of I to be divisible by k, this remainder, this factor should not be there. This remainder factor should be equal to 0. Or we should be removing, if there is some remainder initially in the number a of I, we should be removing this remainder, this part, by adding some number x such that the final number is of the form k multiplied by some t, because it would be divisible by k. So that is what we need. So for this thing, what we will do is, suppose k is equal to 3. Suppose we'll consider the previous example. This was the array given. So if I pick this number, so this 2 can be represented like this: 0 multiplied by this k, which is 3, plus 2. So this is the hurdle which we need to cross for this number to be divisible by 3. So if we add 1 to it, then this becomes 3. This becomes divisible by 3, and this already was divisible by 3, so the overall number becomes divisible by 3, which is the k in this case. So if the number is a of I, we'll be considering the remainder, which would be ai mod k, and we will be adding such a number y so that y is of the form so that y when divided by k leaves the remainder k minus this, because if I add y which is of this form, then this factor gets cancelled with this factor, and this remaining term would be divisible by k. So let's see the approach now. The array given to us was 1 to 1 3. So we'll be so k is equal to 3, and we will be storing the remainders of each of these numbers. The remainder is 1, so these are same only. So on this index I should add such a number y such that y is of the form t multiplied by k plus k minus ai modulus k. K is 3, and this remainder for this particular element is 1. So on this index I should add such a number whose remainder when divided by 3 is equal to 2, so that these remainders gets cancelled and the overall number left in the end is divisible by k. So for this I'll be maintaining a map of int comma int, and I'll be storing the frequency of k minus ai modulus k for every I from 1 to n in this map. So in the map I'll be adding for this index k was 3, so I'll be adding k minus remainder of this 3 minus 1 equal to 2. So 2's frequency is 1 till now. Then I'll consider this. I'll add 3 minus remainder left after dividing this number by k, which is 2 modulus 3, which is 3 minus 2 equal to 1. So I'll add 1 to this map, and then I'll add for this, and this would be 2 only again, so this gets incremented by 1 to 2, and for this I'll be adding 3 minus 3 modulus 3, which is equal to 3 minus 0 and 3. For all the numbers which are divisible by 3 or the k, I don't need to add anything to the map. So this would be the situation of the map. 1 would be present 1 times and 2 present 2 times. This is the situation, and the thing is, the final number that would be added is the maximum value across any key in this map. So this would be 2 minus 1 multiplied by k plus key plus 1. So what I say is, in the end, if the map is like this, I'll see the maximum frequency of any key. So in this case, the maximum frequency is 2. So I'll take this 2 and I'll multiply 2 minus 1 by k, and then I'll add this key, which is 2, and then increment by 1. So this is the formula. So this, when solved, is 2 minus 1 is 1 multiplied by 3 plus 2 plus 1. So this is 3 plus 2 plus 1, which is equal to 6. So I need 6 moves for this particular example. So the thing is, if I again consider the same array 1 2 1 3, let's see, on this particular index I need to add such a number whose remainder is 2. On this index I should add such a number whose remainder upon division by k, which is 3 in this case, is 1. I should add such a number on this index whose remainder upon division by k is 2. And for this is already divisible by k, so I should not be considering this. So I have to do it in minimum number of moves, and x is initially 0. So my approach would be like this. I need to add such a number whose remainder is 2 initially, and in this case such a number whose remainder is 1, and again 2 remainder. So what I'll do is, when x becomes, I'll choose the second move, which is I'll increment x to 1, and when x becomes 1, I see that its remainder upon division by k is 1. So this current value of x is satisfying this particular index. So I'll add 1 into this, and I need to add such a number whose division by k leaves the remainder 2. So I'll add 2 into it, and I should add into this index, on this index, such a number whose remainder is again 2. I cannot add I cannot add this x, which is 2, again at this index. So that is the restriction. So what I'll do is I'll search for the next least number whose remainder is 2 upon division by k. So that would be 5, because 5 when divided by 3 leaves the remainder 2. So I should finally, what I need to do is, in the end, x should be 5 when it is finally added on this index. So I should be doing in the end the first move, that is adding this x on this third index, and incrementing x by 1. So that would take me x, the final value of x plus 1 moves. So now let's code the solution. So we are given t test cases, and in every test case we are given n and k and the array followed by the array. So I'll take the ith, I'll input the ith number into the array, and after this I'll also be maintaining a map of say ll and p, and I'll be adding the frequency of k minus the remainder left after dividing a of I, the ith number in the array, by k. So that is what I'll be doing, and finally when the map gets filled, I'll iterate on the map, and let's suppose the number x is maximum frequency is 0 and maximum remainder is also 0. So if x dot second, that is the value, the frequency, is greater than the maximum frequency, then I'll simply be updating maximum remainder to the key corresponding to that entry, and I'll be updating maximum frequency to the current frequency. And in the second case, if the frequency is equal to the maximum frequency till now, I'll simply be updating maximum remainder to max of maximum remainder and x dot first, the key. And I guess the number would be, the final number x would be maximum frequency minus 1 multiplied by k plus maximum remainder, and for that I'll be needing x plus 1 moves. So I guess this should work. Error, does not name a type. Sorry, this is same. No. Let's do it in the other way. Map.begin using an iterator. So if the frequency is greater than the maximum frequency, I'll be updating maximum frequency to this frequency, and maximum remainder will be set to the key. And the second case is if the frequency is equal to maximum frequency till now, so in that case I'll just be updating my maximum remainder to max of maximum remainder and the key. So in the end, the number that would be added is so the number would be maximum frequency minus 1 multiplied by k plus maximum remainder, and the number of moves would be x plus 1. So let me compile the why am I getting this error? Say we use map int. So it is compiled now, and let me run on a sample case. So for this test case, the output is 6 and 18, 51, 6, 18, and this was 51, but in the answer this is 0. Oh, I should not be adding entries corresponding to the remainder 0. So if ai modulus k equal to 0, then I should simply continue. I should keep a check here only. All zeros. If the array contains all the elements which are zeros, which have remainder 0 only. So if this is not true, that would mean that all the elements are not having 0 remainder, and I should keep a check here. If all 0 is true, then I should simply print 0 number of moves and then continue. Let's again compile it. So now the answer is 6, 18, now it is 0, 227 and 8. So this is correct. So let me submit on Codeforces. This is accepted. Finally the solution is correct after so much time. So that's it for this video, guys. Thank you.